Alright, everybody. So looking at our deal here, it says the length of the arrows is directly proportional to the magnitude of the forces acting concurrently on the submarine. It tells you concurrently means it's they're acting at the same time. And when it says they're directly proportional to the magnitude of the forces, that means that the longer the arrow, the bigger the force. So the way to figure this out, it asks us which direction is this thing going to move, is to look at the vertical one separate from the horizontal one. So let's look at the vertical ones first. The up arrow is bigger than the down arrow. We don't even need to know the numbers to determine, because I mean, first of all, we know it's going to move up since the big arrow's, the up arrow is bigger than the down arrow. But we don't even need to know how much exactly each of them are to figure out how much to draw the arrow. We can just say, okay, this arrow is this long, we need to subtract that much from this arrow, so we're left with about that much. So I'll make my next arrow about that big, like this. And will you face this way, please? And the right arrow is bigger than the left arrow, so I can do the same thing and subtract about that length. So it's going to move right and up. So I would say its resultant force would be just about like that or something like that, which means it'll move up and to the right. So if you picked between up and right, you are correct. So the thing we're doing today is we're going to be doing, it's pretty much the same as the conversions thing that we done did, but this one involves a new formula. We'll be doing work today. You're all shocked. Work is a physics thing. It's force times distance. See, I wrote it up here. Work equals force times distance. See? You see it? Okay. Now, I mean, it's a regular formula. It's pretty regular. It's not quite as easy as like F equals ma, because as you can see, it's got an F right there. So it might give you work and distance and mass, and then ask you, how much is this thing going to accelerate? If it has this much work done for this many meters, I will tell you work is energy in joules. So now we got three different things that are energy. We got work is energy, kinetic energy is energy, potential energy is energy. So right about now, it's going to stop mattering which what your energy is here. Like it's going to stop mattering what it calls the energy it gives you. It just matters that it's energy. So when I write down this energy here, I'm not going to say, it says 160 joules of work. I'm not going to say W equals 160 joules. I'm just going to say energy, because when it starts giving you energy now, you're going to have to decide what kind of energy to, what formula to put that in. And so it's either going to be PE or KE or work. So there's just, you know, one chance in three it'll be work. So I'm just going to say it's energy and then figure out what formula to use, and then I'll know what it goes with. Because work is energy too. They're all energy. E and KE and PE and W. Now, okay. So a person used 160 joules of work to push a 20 kilogram shopping cart, that's a mass, 20 kilograms, across a bumpy parking lot. How fast did it go after they let go? So it's asking how fast. There we go. We're looking for V. All right, there's only one formula that we can use to look for V. So I'll use it. That's this one. That's the only one that's got V in it. So that's the one we got to use. So now it's clear we're not putting this with W, we're putting it with KE. And that's why I just wrote an E, because we had to wait to see what we're going to use it with. And so you solve it just like regular. I'll plug in my energy for my energy thing. And mass is 20 kilograms. And velocity is what we're looking for. So you'll solve this just like regular. I tried to make these where you don't have to use a calculator if you don't want to. So I just simplified it. 1/2 times 20 is 10, and that's the only thing I changed. Now I wanted to say equals V squared, and then I wanted to say equals V. So I need to divide both sides by 10 since it says V squared times 10. That cancels because 10 over 10 is 1, and I'm not going to write 1 v squared, that'd be silly. 160 divided by 10 is 16, pretty sure. See, check this out. And the square root of v squared is v. Square root of 16, I already know what that is 4. So you don't have to use a calculator, but you can. And there you go. So, like I said, it's a lot like the conversions thing we did, except you're using a new formula, work. And there will be some questions just about work, and there will be some questions that make you split up. Instead of f times d, you'll say m times a times d, since f is equal to m times a. I showed how the units are still, why it's still joules over here, because if this is joules, this is what joules actually are. But don't worry about that if you don't want to. Y'all have questions about this? Yep, it ought to be all right. Just another more energy transformations.